How do fireworks or neon sign work? Well, energy is given to atoms through electricity or through oxidation. And this absorbed energy, it has to be released again, and the way it is released is through light. So in the case of fireworks, we have metal salts that are used in order to produce different colors of fireworks. For neon signs, we use the noble gases in order to produce different color signs. So we can add energy through the use of electricity. And the electricity can be passed through a gas. In this case, on the far left side, it is mercury. So the light that is emitted from mercury atoms. In the center, we have helium. And on the far right side, we have hydrogen. And so we're exciting the electrons into a position further away from the nucleus. And when those electrons fall back towards the nucleus, they give that additional energy off as light. We can add energy by exposing atoms to a flame. Different types of atoms will give off characteristic wavelengths that help us to identify which type of metal is present. So sodium gives off a yellow-orange color in a flame. Potassium will give off a purplish color. Lithium is more of a red, and barium is more of a green. Because they have these very characteristic wavelengths of light that are present, they help us to identify the metal. The way that this light is given off is we have electrons that are excited by the flame to an area further away from the nucleus, and as the electrons fall back down towards the nucleus, they give off their light. They give off their energy as light. Because different elements have different colors that we see, we can use those colors to help identify which element is which. By passing the light that they produce through a prism, we see very distinct wavelengths of light that are produced. So it's not the continuous spectrum that white light would give, but just a few wavelengths of light that are characteristic of a particular element. And this helps us to identify the type of element it is. This is part of how they identify elements in distant stars by looking at the emission spectra that we receive here on Earth. So why do we see these emission spectra? This is due to the Bohr model of the atom, where we have discrete energy levels, which are represented by these numbers, n equals 1, n equals 2, n equals 3, and so on. And the transition of the electron from one energy level to another energy level. So if our electron is going from a higher energy level to a lower energy level, it gives off light. If it's going from a lower energy level to a higher energy level, it absorbs light. Depending on the energy level that it is in the transition, we get different wavelengths of light. So if we're going from the 5th energy level to the 2nd, we see violet light for hydrogen. If we go from the 4th to the 2nd, we see blue-green. If we go from the 3rd to the 2nd, we see a red color. Why are these transitions from the 3rd to the 2nd? Why don't we have any lines on here that go to the 1st energy level? Well, that is because the energy would be even the wavelength would even be shorter. The frequency would be higher, the energy would be higher, and so this falls outside of the visible range that we can see. So as we're transitioning between energy levels, if it is increasing in energy level, so going from a low number to a high number, this is the absorption of energy. We need to put energy in to get it to jump higher. If it is falling from a high number to a lower number, it has to give that energy off. And the way that it gives the energy off, the way it emits it, is it gives off a photon of light.